you count. I was lost, but your fool was a long visit round. Say you are the only
8.4 is on geometric series. You should already have a pretty good idea what this is about because we've talked about geometric sequences and we've talked about arithmetic series. If you put the two together, you should be able to figure out what this is. Don't want to think about it for yourself? Here you go. A geometric series is the sum of a geometric sequence. So, for example, last time we looked at geometric sequences, an example of that would be something like 2, and then the next number would be, or could be, I'll make one up, could be 8. Now remember, this is geometric, not arithmetic. If it was arithmetic, we'd gone up by 6, we'd go up by another 6, it'd be 14. But this is geometric. So what did I multiply 2 by to get 8? I multiplied by 4, multiplied by 4 again, I get 32, multiplied by 4 again, I get 128. I could keep going if I want, but I'll stop there. Now if I just list those terms with commas between them, it's a geometric sequence. All I have to do to make it a geometric series, plus, plus, plus. Okay, there are infinite geometric series. They're very, very interesting actually. We'll do them next day. Today they'll all be finite, all our series. Okay, a couple formulas you need to use. Here they both are. And the main difference you'll be dealing with is that the second one has the t sub n and the first one doesn't. So if you know t sub n, you'll probably use this one. If you don't know t sub n, you'll probably use the top one. Don't remember what all these things mean? Let's go through them. S sub n is the sum of the first n terms. So for example, in this geometric sequence right there, if I asked you what S2 is, it doesn't mean what's the second term, 8. It means what's the sum of the first two terms. So it'd be 2 plus 8. S sub 2 is 10. What is A? That's the first term. Well, I don't need to write that down. The first term is 2. What is R? The common ratio. What's the common ratio in this case right here? Well, what have you multiplied every time to get the next term? 4. So R is 4 in this case. N is the number of terms. Well, obviously that's also 4. 1, 2, 3, 4. There's 4 terms. And T sub n is the nth term or the general term. It's also often the last term, or at least the last term that you're interested in a certain question. If I asked you what T2 is, then I am just asking you what's the second term, so the answer would be 8. Okay. Oh, one other thing. You'll notice with both of these formulas, they have the same denominator, 1 minus r. So what can r not be in this case? What would be the non-permissible value? R cannot equal 1, because if it did, then you would end up with 0 in a denominator, and you can't have that. So what would we do if we ended up with a question that does have an r with a value of 1? So for example, here's a question. What if a is 7 and r is 1, and I want to know what the sum of the first 10 terms are? You can't use the formula. Well, sometimes you don't get to use the formula, so you have to actually think about this. If the first term is 7 and the r value is 1, what do you do to get the second term? You multiply by 1. And what do you get? 7. Then what would you do? You'd multiply by 1 again, and you'd get 7. And you'd just keep getting 7, 7, 7. So all your terms are 7. If you want to know what the sum of the first 10 are, since you'd have 10 sevens, it'd be 7 plus 7 plus 7 plus 7. You'd be 10 times 7, which is 70. That would be your answer. I guess I really should have plus, 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 plus here to show that it's a series and not a sequence, and I should have 10 of them, right? But I'm not going to do them all. Incidentally, I believe officially if you're not allowed to have r equaling 1 in a geometric series or geometric sequence, and it also can equal 0. Details. Okay, here we go. Basically what you're going to do is you're going to write down the stuff you know and figure out which formula you're going to use and throw it in the formula. It's not too bad. So determine the sum of the first 15 terms in the following geometric series. Do you know A, the first term? Sure do. It's 40. Do you know R, the common ratio? Not yet, but you could figure it out. Take any term and divide by the previous one. How about I'll take this term right here, the negative 5, and divide by the previous one, 10. If you put that in lowest terms, it's negative 1 over 2, or you could write it as negative 0.5. Do you know what n is, the number of terms? Well, it's an infinite series, but remember, how many terms are we interested in? We're only interested in the first 15, so our n value is 15. Do we know what the 15th term is? Tn or T15 in this case. Do we know the 15th term? No, we don't. That's useful when we're figuring out which formula to use. And do we know the sum of the first 15 terms? No, that's exactly what we want to figure out. So we want to figure out the sum of the first 15, and we don't know the 15th term. So you can't use this one because you would need to know the 15th term. We have to use that one. So that formula is S sub n, or we could say S sub 15, equals a1 minus r to the nth power, all divided by 1 minus r, and we plug stuff in. So a is 40, 1 minus r, which is negative 0.5, raised to the 15th power, because that's what n is, that's a 15, all over 1 minus r, which is negative 0.5. Now you have to be careful here. You might want to throw this all in your calculator. If you have a good calculator, it should be able to figure that out. But if you're not sure, you need to do that, the exponent, before you do the subtraction step. So you're going to get 40 times 1 take away negative 0.00000305. My goodness. All divided by 1 take away negative, that's the same as plus, so 1 plus 0.5 is 1.5. Okay, I guess I should have a second bracket there, shouldn't I? Equals 40 times 1 take away negative is the same as 1 plus, so it's just 1 plus all that. In other words, we get 1.00000305, and divide that by 1.5. Let's just write the answer down now. If you took your calculator and did 40 times this and divided by 1.5, the answer will be 26.67. So the sum of the first 15 terms in this geometric series is 26.67. Next one, the sum of the first 10 terms of a geometric series is blah blah blah. The common ratio is negative 3. Determine the first term. So, do we know a, the first term? Obviously not. That's what we're figuring out. Do we know what r value is? Yeah, the common ratio is negative 3. Do we know n, how many terms we're interested in? Yes, we're interested in 10 terms. Do we know what the 10th term is? So, instead of tn, I'll put t10. Do you know the 10th term? No, you don't. Do you know the sum of the first 10 terms? Yes, the sum of the first 10 terms is negative 29,524. Okay, again, you don't know what the 10th term is. You don't know Tn, so you're going to have to use the same formula we used last time. S10 equals a 1 minus r to the n all over 1 minus r. Do we know the sum of the first 10? Yes, it's negative 29,524. A we don't know. 1 minus r we know is negative 3, and we're raising it to the 10th power. That's what n is. All divided by 1 take away, and r is negative 3. Okay, negative 29,524 equals, again, you want to make sure you do this first. So we have a, and then 1 minus negative 3 to the 10th power equals positive 59,049. And on the bottom, 1 take away negative 3 is 4. Why don't we multiply both sides by 4 now? Because in doing that, we get rid of that 4 on the bottom here. So on the left-hand side, we have 4 times negative 29,524, which equals negative 118,096. And on this side, we can also do this. 1 take away 59,049 equals negative 59,048. All right, last step. We want to get the a by itself, and this a is multiplying by all this, so we need to divide by negative 59,048. Do the same over here. Divide by negative 59,048. On the right-hand side, those cancel, so you're just left with a, and on the left-hand side, you end up with 2. All of that to figure out that the first term is 2. Does it have to be a whole number? No, the first term can be a decimal, it can be negative, it can be what has to be positive? N, the number of terms has to be positive. And the number of terms also can't be a decimal, right? Last one, calculate the sum of this geometric series. Do we know a, the first term? Indeed we do, 6. Do we know r? Well, we can figure it out. Take 12 and divide by the first term, which is 6, and we get 2. Do we know n, how many terms there are? No, we don't know how many terms there are. There's a lot of them, but we don't know how many. Do we know Tn? In other words, the general term, or in this case, the last term? Yes, we do. It's 12,288. Do we know the sum of all these terms? No, that's what we want to figure out. Look, we know what Tn is in this case, so we're allowed to use this formula this time. So let's write that one down. S sub n equals a minus r times t sub n all over 1 minus r. We don't know S sub n, that's what we're figuring out, but we do know 6 for a, we do know that r is 2, and we know that Tn is 12,288, and we're going to divide it all by 1, take away r, which is 2. Again, you must do this before you do the subtraction step. So we get 6 take away 24,576, all divided by 1 take away 2 is negative 1. So now if we subtract, you will end up with 6 take away all that is negative 24,570 all over negative 1, and we divide by negative 1, the two negatives become positive 24,570. The sum of all those terms, even though we don't know how many terms there are, we still don't know how many terms there are, but in this case it doesn't matter. We know the sum of them is 24,570. We could definitely figure out how many terms there are by using the other formula, but it doesn't ask for it. We're done. Okay, use those formulas, plug in all the values you know, and follow BEDMAS. You should be good.
So